All right, guys, last video. All right, it's chapter 13. Okay, so I'll put this here so you can see it. All right, hopefully. All right. How much water at 3 degrees Celsius is needed to cool 0.4 kilograms of copper from 210 degrees Celsius to 16 degrees Celsius? So this is a heat exchange question where the energy lost equals the energy gained. What's losing the heat? The copper. What's gaining the heat? The water. So you do MC delta T equals MC delta T. Now, one of the things I always do is I always make sure that the temperature change is always positive, all right? Because some people will do Q loss equals Q gain and they'll put a negative here for the Q gain. And sometimes you end up getting double negatives and it just becomes a little more difficult. So I just basically say, as always, just put the bigger one in front of the smaller one and you're good. Even it just makes the math a little bit easier. So we've got 400 grams, all right, because it's 0.4 kilograms, 400 grams of copper, okay, times the specific heat of copper, 0.092, times the temperature change. The copper is going from 210 down to 16. 16 is the equilibrium temperature, okay? All right. That is going to be equal to the mass of the water used times the specific heat of water times 16 degrees minus 3, because it's going from 3 up to 16, okay? So when you do the math, you get 7,137.2 equals 13 M, and you end up getting 549 grams of water is what is needed to do this, okay? Like I said, if I had done it where it was 16 minus 210, this would have come out to be a negative, but then you're supposed to have a negative in front of here, and the negatives and negatives just cancel. So it's tomato, tomato, all right? It works either way. Next one is right here. Zoom that down so you can see it. You've got 6 grams of copper at 350 degrees Celsius. We drop it into 75 grams of water at 2 degrees Celsius. We want to know what the equilibrium temperature will be. This is the hardest question, I think, on the test because of the math, all right? And I'm going to walk you through this. You get 6 grams of copper. Here's a specific heat of copper. And it's going from 350 to final temperature. Notice, the final temperature we know is going to be less than 350, so it's over here, okay? Meanwhile, we've got 75 grams of water with a specific heat of water of 1, and then we know the final temperature is going to be higher than 2 degrees, so we'll put that here, minus 2 degrees. We get, multiply these two numbers together, we get 0.552 times 350 minus TF. This is where everyone goes wrong if they get this wrong. You have to distribute the 0.552 into the 350 and the TF. So 0.552 times 350 is 193.2 minus 0.552 TF. Same thing over here with the 75. 75 TF minus 75 times 2 is 150. Okay? Then, because this is a negative, I'm going to add this over to this side, and I get 75.552 TF. And then this is a negative here. I add that over to this side, and the 193 becomes 343.2 equals the 75.52 TF. And when you divide by 75.52, your final temperature comes out to be 4.54 degrees Celsius. Now, one of the things about this question is if you get a temperature that doesn't make sense, you know you did it wrong. When you put a small piece of metal into water, because water specific heat is so high, the temperature is going to increase a little bit, not a lot, right? If you dropped it in and all of a sudden the water was 320 degrees, you know you screwed up, okay? All right, last question. This question is going to count as 2 questions because all the work you're going to have to do. I have how much heat is needed to take 30 grams of ice from minus 45 degrees Celsius to 30 degrees of water. So we're taking that chunk of ice, we're heating it up. It's going to go from the ice is going to heat up from 45 to 0. At 0, it has to use the heat of fusion, or fission, not fusion or fission, wrong word. It has to use the heat of, heat of fusion to totally, completely melt the ice. That's what HF is. And then, once it's all melted, now it can heat up to 30 degrees. So it's 3 steps here. The first part is we do Q equals MC delta T for ice. 30 grams, specific heat of ice is 0.5, times the temperature changes from 45 to 0 is 45 degrees. You get 675 calories. Then we do the heat of fusion formula. 30 grams times the heat of fusion, you get 15,990 calories. See the huge difference in heat? All right? Heat of fusion takes a ton of energy compared to getting it up to that point. Then we're going to heat the water, now that it's all water, from 0 to 30, and that's going to be 900 grams. So you're going to do MC delta T for that. Then you're going to add all 3 of these numbers together and call it Q total, and it's 17,565 calories. That's the total. So this whole thing is going to count as 2 questions on your test, 20 points. And you need to show me all your steps, okay? All right, good luck. And it was a fun year. I just wish we were in person.